This jar contains a few ounces of soil. It looks pretty ordinary, doesn't it? But what you can't see is that it's teeming with life. The microbes inside are poised to become farmers' greatest tool and transform how we feed humanity. I'm Karsten Temme, founder of Pivot Bio, and I have dedicated my career to studying these microbes. They can and will revolutionize agriculture. Give me a sec while I set this down. So from the plow to the grain combine, humans have invented tools to grow more on the same amount of land. Fertilizer is the greatest of these, all those nutrients that a plant combines with sunlight to grow. Here's an example. In the 1950s, American farmers produced 2,600 kilos of corn per hectare. Today, there are yield competitions where the winners can generate more than 32,000 kilos on the same amount of land, in a large part because of the fertilizers they can use to fuel that crop. It's just amazing. But for all the good it does, fertilizer is an inelegant solution. Last year, farmers around the globe spent more than $200 billion on nitrogen fertilizers alone. They spray it on their fields and then pray that roots can find it before it's lost. Because if that fertilizer is lost, the crop can end up starved of its nutrients and stunted in its yields. Those losses also translate to unintended consequences. Some becomes nitrous oxide, a greenhouse gas that's 265 times more potent than CO2. Some seeps into our groundwater, and some runs into our rivers and oceans, creating more than 500 dead zones around the planet. So there's gotta be a better way. And I'm here today to tell you that there is, and it's rooted in biology. You see, 78% of the air around us is nitrogen gas. That's a form that plants can't use, and so they've partnered with microbes on a process called nitrogen fixation. The microbes can breathe in that nitrogen gas and turn it into a form that plants can metabolize. It's a symbiosis, a partnership that's worked for millions of years, right up until the point that humans started breeding crops to be more productive. Those bigger yields needed more nutrients, and fertilizer was invented to fill the gap. Well, microbes in response shut down that nitrogen-fixing function, putting those genes into hibernation. What if we could wake them back up? What if we could use modern tools like gene editing to bring those microbes back to being specialized helpers for farmers? Then we could have a way for those microbes to live with the plant alongside the roots, sensing the crop's nutrient needs and responding in real time. Well, that's a challenge that I set out to pursue 2 decades ago, along with my friend, lab mate, and co-founder Alvin. We made it our mission to get those genes working again. So here's how that went. We collected soil samples from farms across the United States. We extracted the microbes, we reprogrammed their DNA, and we cranked that nitrogen-fixing function to 11. Then one day in the lab, we saw it. There was a test tube with a tiny corn seed germinating. Our microbes were living along the roots of that plant, producing nitrogen and sharing it with that tiny plant. That test tube represented a breakthrough. We had shown that we could create microbes that could sense and respond to the plant's nutrient needs in real time. We thought we had just solved agriculture. Well, spoiler alert, not quite. Across the last 15 years, we have been working to transform this breakthrough into a system that serves farmers on 3 continents today. I believe that across the next decade, we can help farmers reduce half of the fertilizer that they need. So what I wanted to do is take you on a quick little journey to meet 3 of the farmers that are using these microbes right now. So meet John. He's a corn farmer in Michigan who runs a 1,295 hectare farm. Now, it's a complex operation, and he's got a lot of variables to manage, so he doesn't need any more. John's turned to Pivot for the last 5 years to simplify his life. Each year, we've sent him a little less than 4 kilograms of freeze-dried powdered microbes, and he's coated his seeds with the microbes, planted them as normal. Once in the ground, those microbes have gone to work. They eat sugars from the crop, they fix nitrogen and share it back with the plants. And then when the crop's harvested, those microbes die, ensuring they only do what we intend. Now, they're operating at the cutting edge, alongside satellite mapping and soil monitoring, slow-release fertilizers, and precision machinery. It means that yields at John's farm have boomed. His dad regularly applied more than 225 kilos of nitrogen fertilizer per hectare and generated about 8,500 kilos of corn. Today, John's able to apply less than 140 kilos of fertilizer, and yields have risen to 11,500 kilos on that same land. It's amazing, and what it gives me the most pride is that our microbes are helping make his job easier while increasing his bottom line profitability. And John's not alone. Our microbes have been used on as much as 5% of the US corn crop. So if you'll zoom with me about 7,000 kilometers south, I'd like to introduce you to Charles. Now, Charles runs a large farm in Brazil. Brazil is an agricultural powerhouse. It's one of the world's top 3 corn producers. Yet, yields average just about 6,000 kilos per hectare, so there's a lot of room for upside improvement. One of the biggest limiting factors is nitrogen fertilizer. Brazil imported more than 80% of its nitrogen fertilizers last year, and that's something it's looking to reverse through microbes, both with us and others. So Pivot's been working with the Ministry of Agriculture to test and adapt our products ahead of commercial sales. And I'd like to give you a little bit of a look into Charles' farm, where he's counting on those microbes to supply about 30 kilos of nitrogen alongside the 120 kilos of nitrogen fertilizer he's applying every acre. That's about 25% less than he normally would use. Now, the crop's a couple weeks away from harvest, but what you'll see is the plants are larger, greener, they're healthier, they've got bigger root systems. All that sets up the crop to be more resilient in the face of an unpredictable climate. It also means that's a bigger factory for producing higher yields at better profitability. This is a boon for Charles's operation. It's also an opportunity for Brazil to have strategic independence, because these microbes can be brewed like beer close to the farm. That means no more reliance on foreign chemicals or global supply chains. We're also working in Kenya, and I'd like to introduce you to Margaret. Now, every morning, Margaret wakes at 4 a.m., and she walks 5 kilometers to reach her small plot of land. For her, fertilizer isn't just an expense. It's a significant investment. $36 for a 50-kilo bag. She applies it by hand and then prays that the rains don't wash it away. Because all it takes is one rainstorm, and that investment is washed away. And with it, her family's security is upended. So this is where the limits of fertilizer are most apparent, where there's no margin for safety. So what Pivot's done is we've teamed up with MIT and local partners to adapt our product and supply chain to work for smallholders like Margaret. We've shrunk our packaging. We've built a just-in-time network where farmers can text the day they're ready to plant, and we can motorbike them the freshest microbes possible. The results are astounding. Not only are the crops more resilient to those rainstorms, yields have improved 60%. You know, the biggest complaint we've received is farmers say, you haven't told me what the product is or where I can buy it. So I started with this jar of soil. The microbes inside have already transformed how fertilizer works across millions of hectares, making it smart, dynamic, living. Since 2022, farmers have been able to prevent more than 1.3 million metric tons of greenhouse gases. What's needed next is to be able to scale this system across hundreds of millions of hectares. And here's what that's going to require. It's going to require creating a global network for microbial manufacturing. But it's different than building fertilizer factories that cost billions of dollars. Biomanufacturing can scale at 1/200th the cost. It also gives us an opportunity to rethink supply chains to make them local and flexible. So in Michigan, that might mean FedEx is the best way to deliver those microbes, and a motorbike in Kenya might be the best last-mile solution. And what excites me the most is that we can spread a web of agronomic knowledge to connect farmers like Margaret, Charles, and John together, helping them share knowledge with each other on the best way to put these microbes to work, to not just increase yields, but to improve efficiency and profitability. You see, when we build infrastructure on top of these microbes, we're not just deploying a new type of product, we're building a better way of farming, one that works with nature and not against it, helping farmers grow more with less. Soil is our oldest agricultural technology, and it's the next frontier. With the microbes in here, we can empower farmers to grow the future from the ground up. Thank you.